Okay, so here we have some of everybody's favorites, theorems. So before we had shown and we had proven congruence of triangles, but now we're talking about similarity of triangles. And so to prove triangles similar, there are three theorems. There's angle-angle, side-side-side, and side-angle-side. Now, side-side-side and side-angle-side are should be familiar because we did them when we proved congruence of triangles. And what we did was we showed that all three sides were congruent. Here, three sides were congruent, and the angle was congruent. But we're talking about similar triangles. So with similar triangles, remember that the sides aren't congruent, they're proportional. So with angle-angle, if we can show that any two angles inside of a triangle are congruent, then the triangles are similar. So angles must be congruent, but the sides, so for side, 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 if these three sides are proportional, then that shows that they are similar triangles. So for example, with these two triangles, you can see we take each side, each distance here, this is A, and we multiply it by some common ratio, scale factor, x. So because we're multiplying those by x, by some value, those sides stay proportional, and so the overall triangles are similar. We can also show two sides being proportional with the angle in between those two sides being congruent, and that is the side-angle-side similarity theorem. So we use these to prove triangles being similar. But before we get into that too much, let's get some more practice with these types of problems where we have to solve for x and y. So we know that each of these triangles in number one is similar. So that means that the sides are proportional. So here, the smaller to the larger one is 10 to 20, which is 1 to 2. So the smaller hypotenuse, or the longer side here, is y to 35. So that means that 35 is equal to 2y, and we get that from cross multiplication. And so then we just have to divide both sides by 2, and so we get 17.5 is equal to y. We could do the same thing, so the same ratio, 10 to 20 or 1 to 2 is equal to 13 to x, and so that gives us that 26 is equal to x. Um, 1 to 2 is equal to y to 35, yep. 1 to 2 is equal to 13 to x. Yeah, that looks good. So hopefully this makes some sense there. We've done this before. With number two, though, it comes a little bit challenging because we have actually two overlapping triangles. So this whole distance here, we have to be careful. This whole distance is 26 plus 13, which is 39. So this small triangle, 26, is to the large triangle, 13. Well, that's just 1 to 3 because we can factor out 13 for both of them. Sorry. 2 to 3. Because we can factor out a 13 for both 26 and 39. So that scale factor 2 to 3 can be the same as the other sides. Now, this is nice. They give us this notation here. So they tell us that this side and this side are congruent, so that's going to be 13. Yeah, there are actually a whole bunch of different ways to do this. Keeping with proportions, there's another way to solve for x. Actually, there's a few different ways I'm saying. But we can keep with proportions, so we get 2 to 3, so that's 26 to 39, is equal to x plus 2, 2, x plus 15. How do we get this x plus 15? Well, the 2 plus 13 is 15. So then we can cross multiply, so we get 2x plus 30 is equal to 3x plus 6, and we get that x is equal to 24. Notice that these two sides are the same, so we could have also said that x plus 2 is equal to 26 and have gotten x equals 24. Now for the y and the 20, for y, we have to use proportions. So we set up that same scale factor, 2 to 3, so 2 to 3. This distance here is from the smaller triangle, and that's 20, and the larger triangle is y. So we get 2y is equal to 60, or y is equal to 30. Three looks a little bit challenging as well, but like we said before, we can see these overlapping triangles. So this is 24, that larger one is 26. So the scale factor from small to large is 24 to 36. And so we can divide these both by 12 to get 2 to 3, again, as that scale factor. Okay, so yeah, I'm thinking, well, let's find y first. Let's find y first. So 2 to 3 is the small to the large. And the small triangle has this side y going across, and the large triangle has 36 root 2 going across. So we can multiply both sides by, or we cross multiply, so we get 72 root 2 is equal to 3y. And so we can divide that by 3, and actually 72 divided by 3 is 24. So we get 24 root 2 is equal to y. Now there's some cool stuff going on here with the root 2, and actually this is a special case triangle which we will look back at later on. But because this larger triangle is an isosceles triangle, notice these values, we can go off the assumption that this side is also 24, making this side 12. So this side would also be 12. So x would be equal to 12. If we want to set up a proportion, which is a good idea, we can say that 2 to 3, so small to large, is equal to 24 over, this. In this case, this would be x plus 24. And so we could cross multiply to get 2x plus 48 is equal to 72. So 2x is equal to 72 minus 48, which would be 24. So x would be equal to 12. So that's a little bit more of a mathematical way to get that answer. And then finally we have number 4. And this is a little bit rotated around. So we can actually see that because this angle is congruent to this angle, that if we take this larger triangle and rotate it around, that's going to be the order of the sides. So 30 to 60, that's the same as 1 to 2. That is our scale factor. So that means that this side 23 and y are actually going to be corresponding. So 1 to 2, so small to large, is equal to 23 to y. So we get that y is equal to 46 from cross multiplication. For x, so if we do the same 1 to 2, the small to large 1 to 2 is equal to x to 38.6. So we get 38.6 is equal to 2x. So that means that x is equal to 19.3. Because this smaller one is going to be half of that. All right. Now let's actually look at some situations here where we have to show whether or not these are similar. So don't forget we have these theorems, and sides must be proportional, angles must be congruent. So here we don't have any angles, but we have three sides. So if we can show that these three sides are proportional, have the same scale factor, that means that they are going to be congruent. So if we go through here, we can see 13 to 21 must equal 9 to 12, and that must equal 14 to 20. So as long as all of these are the same, we should be good. Well, let's take a look at this. So 9 to 12, we can reduce that by common factor of 3. So that becomes 3 to 4. 4 to 20, they both have a common factor of 4. So we can reduce that. So that becomes 4 to 5. And then this stays 13 over 21. Well, it might be easier for us to get decimal approximations, but if we really think that or understand that 3/4 is equal to 0.75 and 4/5 is equal to 0.8, we can see that these two are not the same. I mean, hopefully we have a better understanding of fractions. We can see that they're not the same. But if we struggle with that, we can convert them to decimals and see definitively they're not the same. So these are not similar. So for number 1, these triangles are not similar because the sides are not proportional. For number 2, it looks like they're rotated around, so we can actually say 8 to 6 is equal to 12 to 9 is equal to 12 to 9. So we can use these similar sides, the same sides. We can reduce all of these. So 8 and 6 reduces to 4 to 3, and 12 to 9 reduces to 4 to 3 as well. So because all of these are the same, yes, these are similar. So triangle ABC is similar to triangle, we could say PQR. And that's because of side, side, side. So note I throw that theorem in there as well to correctly label my response. Here they give us this angle, so the two angles are congruent, which is great. So if the sides are proportional, so if 10 to 15 is the same as 14 to 21, that means that these triangles are similar. So 10 to 15, that is 2 to 3. 14 to 21 reduces to 2 to 3 as well. So yes, these are similar. So we can say triangle TSU is similar to triangle PJM, and that's because of side angle side. And then the last one over here, yet again we can see we have two 30, 60, 90 triangles, so the angles are all congruent. So, oh well, so they don't give us any sides, so we can't figure this out yet. We'll be able to later. But because we have a 90-degree angle and a 60-degree angle, yes, these are similar. So triangle SKM is similar to triangle RTQ in the corresponding order. And that's because of angle-angle. So angle-angle says all you need to do is show two angles. Here I showed three angles, but really all we need to do is show one other angle in addition to what was given. And that shows us similar triangles. So that's pretty much it. So you want to make sure that you know the theorems, but if you spend a good amount of time before remembering those theorems to prove triangles being congruent, then the theorems for showing that they are similar aren't too different and aren't too much more challenging. So get some good practice with still setting up your fractions, working with fractions, reducing fractions, and then you'll be fine with this. So best of luck.